Imagine waking up to a world where the sun is frozen on the horizon, a brilliant, unmoving arc of light. The birds are silent, the wind is dead still, and the only sound is a low, ominous groan from deep beneath your feet. Then, the world tears itself apart. This is the reality we would face if the Earth, our great blue marble, ever stopped its spin. It is a scenario straight out of science fiction, but exploring it is one of the best ways to appreciate the delicate balance of forces that keep our world so remarkably stable. Now, to understand the utter catastrophe of a sudden stop, we first have to understand just how fast we are moving. At the equator, the Earth's surface is rotating eastward at a staggering speed of roughly 1,670 km per hour, or over 1,000 miles per hour. This is faster than the speed of sound. The only reason you don't feel this breakneck speed is that everything around you, the air, the trees, the oceans, the very ground beneath your feet, is all moving at the exact same velocity. It's a finely tuned system of mutual motion. Now, imagine flipping a switch and turning that motion off instantly. This is where our scientific nightmare begins. The first and most immediate consequence is the sheer, brutal power of inertia. Sir Isaac Newton's first law of motion states that an object in motion stays in motion unless acted upon by an external force. And that law would become the planet's ultimate executioner. While the Earth's crust screeches to a halt, the atmosphere, the oceans, and literally everything not bolted to the bedrock would continue moving eastward at that immense speed. The result would be a global, apocalyptic supersonic wind. To put this in perspective, the strongest wind gust ever recorded on Earth was a catastrophic 407 km per hour. The 1,670 km per hour wind from a sudden stop would be 4 times more powerful than that, scouring the planet clean of anything not fused to the continental bedrock. The atmosphere itself would become a global sandblaster, capable of flattening cities, uprooting forests, and erasing entire landscapes. The devastation wouldn't be limited to the air. The oceans, equally bound by inertia, would not stop. They would continue to surge eastward, creating megatsunamis of incomprehensible size. We're not talking about the waves you see in a disaster movie, we are talking about walls of water kilometers high that would sweep across continents. The very crust of the Earth itself, a thin shell of rock, would also be subjected to unimaginable torsional stress, and this might be the final blow. The sudden halt and the subsequent lurch of the planet's mantle would trigger earthquakes and volcanic eruptions on a planetary scale, shattering the surface and reshaping the very geography of the world. But let's say, hypothetically, that the stop isn't instantaneous. What if the Earth's rotation slows down over days, weeks, or years? While it would spare us from the immediate relativistic cataclysm of a sudden stop, the long-term consequences for the climate and geography are equally fatal. One of the first major changes would be the planet's shape. The Earth is not a perfect sphere, it is an oblate spheroid, slightly bulging at the equator due to the centrifugal force of its spin. If that spin stops, the centrifugal force vanishes, and the planet's mass would begin to redistribute itself into a perfect sphere. This might sound like a minor geometric change, but it is a geological catastrophe. The ocean's water, held in place at the equator by that centrifugal bulge, would respond to the change in gravity and the planet's new shape. The result would be a radical redistribution of the planet's water. Enormous volumes of water would rush away from the equatorial regions and towards the poles. The ocean depth at the equator could drop by as much as 8 kilometers, leaving a massive, continuous supercontinent encircling the middle of the globe. While the Arctic and Antarctic regions would be submerged under 2 massive, separate polar oceans. Everything north of Spain would be underwater, as would all of Antarctica, while the equator would become a vast, uninhabitable desert. This is a fundamental, permanent change to the face of the planet. With the rotation gone, our concept of a 24-hour day becomes meaningless. The defining feature of a non-rotating world is that a single day, defined by the sun's apparent motion, would last an entire year. There would be 6 months of continuous, unrelenting daylight, followed by 6 months of freezing, perpetual night. The temperature differences would be staggering. The half of the planet exposed to the sun would be baked for half a year, with temperatures rising well beyond 100 degrees Celsius in many areas, boiling away any remaining lakes and rivers. Conversely, the night side would plunge into a deep freeze, with temperatures dropping so low that the atmosphere itself could condense and snow out of the air. The only potentially habitable zone would be a narrow twilight strip, the terminator line between day and night, where one could theoretically live a nomadic life, forever chasing the sunset. Life as we know it, dependent on stable, predictable seasons and temperatures, would be utterly impossible over most of the planet. The climatic effects would be further amplified by the total breakdown of our weather systems. The Earth's rotation is the primary engine for many of our global wind patterns and ocean currents. It is the cause of the Coriolis effect, which deflects winds and gives hurricanes their characteristic spin. On a stationary Earth, the Coriolis effect would cease to exist. While this might sound like a relief, the reality is that hurricane formation would stop, but the absence of this force would lead to even more extreme weather patterns. Instead of circulating warm air from the equator and cold air from the poles in predictable bands, the planet would develop a single, massive convection cell per hemisphere, with air rising at the scorching equator and sinking at the freezing poles. This would create a global, non-stop atmospheric conveyor belt, whipping incredibly fierce winds from the day side to the night side that would be far more violent than any storm we have ever known. The final blow, and the most insidious long-term threat, would be the collapse of Earth's magnetic field. While the exact process is complex, the current scientific consensus is that our magnetosphere is generated by the dynamo effect created by the rotation of the Earth's liquid, metallic outer core. This magnetic field is our planet's invisible shield, protecting us from the constant bombardment of harmful solar radiation and cosmic rays. If the Earth's rotation were to stop, the movement of this liquid metal core would eventually cease, and the magnetic field would fade away. Without this shield, the solar wind, a constant stream of charged particles from the Sun, would slam directly into our upper atmosphere. Over millions of years, this could strip away our atmosphere, leaving us just as barren and exposed as Mars is today. The loss of the magnetosphere would, in the long run, make the planet completely uninhabitable for any complex life. Now, before you start building an underground bunker, it is important to stress the crucial update to this whole discussion. While the scenario is terrifying, it is also physically impossible. There is no known natural force that could simply stop the Earth's rotation. The planet possesses an immense amount of angular momentum, and as Newton's first law states, an object with that much momentum will keep spinning. While its rotation is slowing down due to the tidal forces of the Moon, that process is so infinitesimally slow that it would take billions of years to bring it to a halt. Even then, it would more likely become tidally locked with the Sun, like the Moon is with Earth, before it ever stopped entirely. In fact, recent scientific studies have even shown that the Earth's rotation rate is being subtly influenced by our own changing climate and global warming, affecting the length of our day, but this is a variation of mere milliseconds over decades, not an existential stop. There is even recent research suggesting that the Earth's inner core might be slowing or changing its rotation, but this is a deep internal process that has no bearing on the surface's rotation or the magnetic field, and it is still a subject of ongoing scientific debate. So, take a moment to appreciate the silence of a planet that keeps spinning, protecting, and nurturing you. The gentle breeze on your face, the predictable rise and fall of the Sun, the safety of a hidden magnetic shield, these are all gifts of a planet in motion, a silent ballet of physics that allows us to live, breathe, and dream, safe on our little, spinning world.